Hello. Uh, Good afternoon, my dear student. Today, we are going to learn another important virtual lab related to the what we can say that study of it is available here, which is nothing but this. I will show you study of a series RLC circuit. This is the lab which is available there. Here you have to go see here which lab is there, analog signal network and measurement theory. So we have to go to here. That is nothing but the list of experiment where we are you are observing here. That is nothing but this RLC circuit analysis. You just have to click here. Now see what is we have to study. That is nothing but the series RLC circuit. Now why it is called as nothing but the series RLC circuit? You can see here this the diagram related to this particular series RLC circuit is given here. Now what these particular resistance, inductance and these capacitors, all these three equipments are connected in the series. That's why this circuit is called as nothing but the series RLC circuit. You can see here resistance, here inductance, and here it is nothing but this capacitance. Okay. The voltage across this particular resistance is nothing but this VR. Then voltage across this particular inductor, that is VL, and the voltage across this particular capacitor is nothing but this VC. And the total voltage across this whole circuit, which is nothing but the V, and the current flowing through this circuit, that is nothing but this R. Okay, so we are interested into the finding out the value of the resistance, that is nothing sorry, the voltage across this particular resistance, then voltage across this inductor, and this voltage across this particular capacitance. Okay, now we are having here, see, just a minute, here the phasor diagram is given. Okay, now as you know that in the theory lecture we have studied this particular phasor diagram. What will happen when your inductive reactance is greater than the capacitive reactance? How is the phasor diagram? That is shown into the figure number 2. You can say that that circuit is nothing but the inductive circuit. Why we have called this as inductive circuit? Because here into the series RLC circuit, the inductive reactance, that is XL, is greater than the XC. And here the second, see this particular diagram. In this diagram, whatever the values of XC, that is nothing but the capacitive reactance is greater than the XL. So this is the second phasor diagram which is related to this particular series RLC circuit. Now what we have to do, we have to first of all see the procedure, then we have to go to the simulator and see what will be this particular output is there. Okay, now see procedure is given here. Now see, it is nothing but this particular circuit diagram, or you can say experimental setup for this particular series RLC circuit. Here you can see this is nothing but this auto transformer 230 volt 50 hertz. See, they have shown here, this is nothing but this particular auto transformer which is they have shown. Now see, we have to this whatever this particular, this is nothing but the millimeter that we have placed here for this particular measurement of current. This is nothing but the VS, that is voltage. This is the you can say MLCV, that is nothing but this particular wattmeter which is connected in order to measure the power. And here it is our circuit, that is this is nothing but this R, this is nothing but L, and this is nothing but capacitor C. Now the voltage across this particular resistance, here it is nothing but the VR, whose what I can say, they have given which particular voltmeter range we have to use, 0 to 150 volt. Then VL, that is nothing but the voltage across this particular inductor, which is again we are using 0 to 150 volt. And this is nothing but the voltage across the capacitor, that is nothing but the 0 to 150 volt. Now see that what is the procedure they have given. See, first of all what we have to do, connect the circuit as shown in the figure. Okay, then what we have to do, we have to adjust the rheostat, and accordingly we have to switch on the supply. Okay, then adjust the voltage across the circuit, that is nothing but the 70 volt, that is it is shown here. This is nothing but this particular Vs that we have to adjust, which is nothing but the 70 volt. And then we have to take down the different reading, that is nothing but the we have to take the reading of this particular voltage across resistance, inductance, and the capacitance. Okay, and after that, by changing the values of this particular inductor or capacitance, you can also take down the same reading, so that what it will happen, whenever you are going to getting all this value, practically it is possible for you to draw this particular phasor diagram by taking the reference of this, that which we are going to study it into this particular our theory, what I can say chapter, where how whenever the value we are getting, how to draw the phasor diagram based on it. Okay, now see here, this is the whatever this particular experiment procedure is given. Now this is the simulator that which we have to use. What they have say here, click here to perform the experiment. Whenever I'm going to click here, the windows will going to appear like here. Okay, so first of all, see, I will just sometime minimize it so that you can clearly see it. Okay, okay, now see it, this is the series RLC circuit they have given. First of all, what is our duty? What, see, as you saw that procedure is also given, but here it is also procedure given. Close the switch K. Now where it is switch K, see, you can see here what we have to do. We have to close this particular switch and set the input voltage V in, that is 220 volt. See here it is the input voltage that we have to vary. I'm going to set it to this 220 volt. I have set it here. Now set the power supply Vs at 0 volt. Now see what, how we are going, I'm going to give it here. Okay, you can observe here, whenever I'm going to vary this particular, it is also going to be varied. But what we have to do, we have to set up to the what 0 volt. Just have on this particular circuit. Now see here, you can observe this particular here, it is that. Okay, Vs, I have to go to the shift to the 0. I am going to shift to the 0. Okay, when Vs is nothing but this particular 0 volt, that is nothing but we are getting this particular waveform. There is no change into this particular. Okay, now what they want to say is that adjust the voltage across the circuit here, that is nothing but this 70 volt. Now where we are going to see that particular voltage, see, whenever I'm going to vary this particular here onto this particular side, here it is near to this particular which side here. Okay, here you are observing this particular Vs. Okay, now see, I'm going to vary it. As soon as it will comes to this particular 70 volt, I'm going to just yes, it is 70.4. Then what I have to do, I have to note down the current, then Vs, VL, Vr, and power from this particular meter. So where I can note down this all these things here into this particular, what can I say, milliammeter, sorry, ammeter. I'm going to take the reading of the, what can I say, current. Then this is the reading for this power, which is going to be measured into the watt. And the very important case is here, that is nothing but this, whatever this reading which we are getting here, that is nothing but this voltage across this resistance. Then whatever this reading that we are getting here, that is nothing but the voltage across inductor. And whatever the ratings that whatever the we are getting here, that is nothing but this voltage across the capacitor. Now what I am going to do, just I am filling this into particular table. See, whatever we have given here, that is appeared into this particular observation table first. That is our Vs is nothing but the 7.2, current into the ampere 2.11, power into the watt, that is nothing but the 112.21. Then voltage across the resistance 52.96, then voltage across this particular inductance, that is 39.92, voltage across this capacitor 48.17, and whatever this angle is there, phase angle, it is given here. Okay, now what again, adjust the now what they are saying, we have to change this value of this particular rheostat. Okay, they are saying that as per this step number 4, what we have to do, we have to change this particular value of the rheostat. How to change this particular value? See here, it is given here. Okay, I am going to change. What is that? If it is 25, I am going to make it as the same. It is up to the 30. So see here, whenever I am going to change it to the 30, what it will happen? All readings related to this going to be changed. Means the value of current is going to change, the power is going to change. Then this voltage across this particular resistance, inductance, and capacitance is going to be changed. And where I said fill to the table, so you can observe with the changes. Baga, you can observe the change here. Current is going to be decreased, then power decreased. The voltage across the resistance is going to be increased. Then voltage across the inductor is going to be decreased. Capacitance is also going to be decreased. Okay. Now see, these are the difference. You can give the different values of this particular resistance, and you can observe the different changes here. But also it is possible for you to change the different values of the inductor also, or you can change the different values of the capacitance also. Okay, now see, I will change this particular value of inductance. If I will change to this particular, what can I say, 30. So see here, you can observe change here. Values of capacitance, the current is going to change, the wattage power is also going to change, then resistance value, voltage across inductors, and capacitance is going to change. And when I will say fill it into the table, I am getting this particular all values. It is not like that only after the changing the inductor you are getting this value. Whenever I will change the value of capacitor also, if I will increase that value, so see here, I will make it as the 70 microfarad. Now what will be this particular value? You are going to observe all values are changed. If I will enter here, fill it into the table, you are saying all the different values, these are observed here. Okay, now see what we have to do. As we know that we have studied it into the theory, that whenever the different values of inductor voltage across the resistance, inductance, and capacitance is given to us, how to find out this particular, or how to draw this particular phasor diagram. But see here, from this particular, what we are observing or what we are getting, that how the performance of this particular series RLC circuit, or how to analyze this particular series RLC circuit with the help of different parameters. Okay, this experiments covers the different points, like whenever we are going to change the values of resistance, inductance, capacitance, the values of voltage that is going to be changed. Okay, and see, as they are connected into the series, okay, that's why this circuit is called as nothing but the series RLC circuit. Okay, in this way we have to perform, or we have to analyze this circuit, or we have to study this series RLC circuit.